Day 520 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 417, Pacific Atlantic water flow. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. There's an N by N rectangular island that borders both the Pacific Ocean and Atlantic Ocean. The Pacific Ocean touches the island's left and top edges, and the Atlantic Ocean touches the island's right and bottom edges. The island is partitioned into a grid of square cells. You are given an N by N integer matrix height where heights R and C represent the height above sea level of that cell at coordinate RC. The island receives a lot of rain, and the rainwater can flow to neighboring cells directly north, south, east, and west if the neighboring cell's height is less than or equal to the current cell's height. Water can flow from any cell adjacent to an ocean into the ocean. Return a 2D list of grid coordinates results where results of I is equal to RICI denotes that rainwater can flow from cell RICI to both the Pacific and Atlantic Oceans. All right, y'all, so I can understand how that may be a little bit difficult to understand. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in our example one, we have this input heights equals a 2D array of integers. These are the array of integers right here. Then our output is represented right here by each coordinate that fits the requirements that they give us above here, where it can the water can flow into both the Pacific and Atlantic Oceans. Sorry, y'all. Boom. So that's what each one of these output coordinates represents. And then the explanation tells us how they can do that. So let's take a look at this picture as we go through this explanation so we can really understand what's going on. So first we have our input heights, right? So you can see each array inside of heights, inside the initial array heights represents a different row. So this would be row 1, or excuse me, this would be row 0. Sorry, the first row, but it'd be row 0. This would be row 0 right here. This would be row 1 right here. This would be row 2 right here. This would be row 3 and row 4. Boom. So as you can see, each element in this array corresponds to this row right here. So it goes 1, 2, 2, 3, 5. That's what this array says right here. And then, so that's how that works. Then each one of these coordinates is a coordinate of a cell that can flow to both the Pacific and the Atlantic Ocean. So it's important to remember that for it to be able to flow to both the Pacific and Atlantic Ocean, each neighboring cell must be lower. So say we're starting right here at 5 and it wants to flow to the Pacific Ocean. It can flow this way because 4 is less than 5 and 2 is less than 4. So boom, it makes it to the Pacific Ocean. Similarly, it can flow this way because 3 is less than 5 and 1 is less than 3. So it can flow this way to the Atlantic Ocean. So think of it as more of a, like this is a hill, and as it goes down, it's going down the hill from 5, 3, 1, and then this side is a hill going down the hill from 5, 4, 2. Boom. And it could also flow this way. It could go up this way to the Pacific Ocean, or it could go down this way to the Atlantic Ocean, because it says right here that the cell's height is less than or equal to. So in this case, if it went down this way, 1 and 1 are equal, so it would still be able to flow to the Atlantic Ocean. So that's what we want to do, and then it highlights each cell that where it's possible, but we're not returning the cells, we're returning the coordinates. So let's go through this example so you can see how these coordinates work. So in the example, in the first explanation, we have 0, 4. So 0, 4 means we come to this. I don't know why 0, 4 starts at the top, but it does. That's how it works. Or actually, 0, 4 stands for this array, this 0 index array, right? Or excuse me, this array at index 0 of this 2D array. So this is a 2D array. This array right here would be index 0 of that array. This array right here would be index 1 of that array. This array right here would be index 2 of that array. So when we come right here, we see 0. So we're going to check this array at index 0. Boom. Then it says 4. So we're going to come to index 4 of that array. So we're going to go 0, 1, 2, 3, 4. So that's this 5. Or you could do it up here. This would be this row would be 0, and then we come over 4. So we go start at row 0, then we come over 4, 0, 1, 2, 3, 4. So either way, we end at 5, right? This is index 4 of the array that is at index 0, right? So the array is at index 0, then we're going to index 4 of that array. So once again, this array is at index 0 of this 2D array, and we're coming to index 4 of this array, which would be 0, 1, 2, 3, 4. So we're looking at this 5 right here in this array. And in the grid, this 5 is right here. So as you can see with this 5, it could go straight to the Pacific Ocean and straight to the Atlantic Ocean. So that's what that means. 0, 4 is already at Pacific Ocean, and it's already at Atlantic Ocean. It doesn't really need to flow anywhere. It already borders both. So then let's look at it says coordinate 1, 3. So 1, 3, once again, if this is 0, then we come down to 1, then we go over 3, starting from 0. So 0, 1, 2, 3. So this is index 3, or excuse me, this would be coordinate 1, 3. And once again, just to show you in the input, this would be index 1. Then we come over to index 3 of that index 1 array. So it would be 0, 1, 2, 3. Once again, it's this 4 or this 4 right here. And so it flows to the Pacific Ocean. It shows us right here the path it'll take. It'll go from 1, 3 to 0, 3. Now we're at the Pacific Ocean. And then it goes from 1, 3 to 1, 4. So right here from 1, 3 to 1, 4. And now it's at the Atlantic Ocean. Boom. And so that's what this shows right here. It shows it going from 1, 3 to 1, 4 and 1, 3 to 0, 3. Once again, this is 1, 3. This is 0, 3, Pacific Ocean. This is 1, 4. Oh, excuse me, this is 1, 3. And this is 1, 4, Atlantic Ocean. That's what this shows right here. 1, 3 to 0, 3 and 1, 3 to 1, 4. Then we have 1, 4, 1, 4. So 1, 4 would be, once again, come down to this row, then go over 4. So 0, 1, 2, 3, 4. Or you could look at here, index 1 of the arrays, index 4 of the index 1 array. So go 0, 1, 2, 3, 4. So this is index 4. So now we're looking at this 4 right here, y'all, or this 4 right here. And it's so 1, 4 to get to the Pacific Ocean has to go from 1, 4 to 1, 3 to 0, 1. So it goes from 1, 4 to 1, 3. And then, hold on. So we go from 1, 4 to 1, 3 to 0, 3. So we go from 1, 4 to 1, 3, then to 0, 3, and we're at the Pacific Ocean. Boom. So as you can see, these are equal. Then we come right here, and this is less, and that gets us to the Pacific Ocean. Boom. So that's how we get to the Pacific Ocean from 1, 4, from this 4. We go boom, boom. We go from boom, 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 boom. We're at the Pacific Ocean. From 1, 4 to 1, 3 to 0, 3. And then 1, 4, it already touches the Atlantic Ocean, so we don't need to do anything here. So that's how 1, 4 is one of those cells where it can reach both the Pacific and the Atlantic Ocean. Boom. Then we have 2, 2. 2, 2 can also reach the Pacific and the Atlantic Ocean. And this is how it reaches the Pacific Ocean. This is how it reaches the Atlantic Ocean. So let's go through it. So to get to 2, 2, so this is index 0. This would be 0. This would be 1. This would be 2. So now we want index 2 of this array. So we go 0, 1, 2. So that would be this 5. And up here, we go from 2, 2. So we go 0, 1, 2. Then we go over 2, 1, 2. So that's this 5 right here. Now, starting from this 5, how do we get to the Pacific Ocean or the Atlantic Ocean, right? So it's going to tell us we go from 2, 2 to 1, 2 to 0, 2 to that's the Pacific Ocean. So right now, we go from 2, 2 to 1, 2 to 0, 2. We're at the Pacific Ocean. So we go this direction. They give us this direction. Then to get to the Atlantic Ocean, we go from 2-2 to 2-3 to 2-4. So we go 2-2, 2-3, 2-4. Now we're at the Atlantic Ocean. Boom. Then we have another coordinate right here, 3-0. So 3-0 could go to the Pacific Ocean. Well, first let's find 3-0. So we have to go to, this is 0, this is 1, this is 2. So this would be 3 and index 0. So we're looking at this 6. And then down here, we're at 3-0. So we come down 1 or 0, 1, 2, 3, and go over 0. So this 6. We're looking at this 6 right here. Boom. So let's see how we get to the Pacific and the Atlantic. We're already at the Pacific right here. Boom. To get to the Pacific, we're already there. So let's see. 3-0, already at the Pacific. To get to the Atlantic, 3-0 to 4-0, we're at the Atlantic. So we're at 3-0, we just come down to 4-0 because 5 is less than 6. So we could come down there and we're at the Atlantic Ocean, and it was that simple. Boom. So now let's check 3-1. So once again, let's see, index 0, 1, 2, 3. So we're looking at this array and we want index 1. So now we're looking at this 7. Boom, and similarity, come down 0, 1, 2, 3, over 1 at this 7. Boom, so we're at this 7 now. So let's see how we could get to the Pacific and the Atlantic from this 7. So we could go from 3-1 to 3-0, we're at the Pacific. So that's just going from this 3-1 to this 3-0. Now we're at the Pacific. 6 is less than 7, so we could take that path. And then we could go from 3-1 to 4-1, and we're at the Atlantic. So right now we're right here at 3-1. Then we just come down to 4-1, and we're at the Atlantic right here, so we could take that path. So we just go like this because 1 is less than 7, so we could go down that hill as well, and now we're at the Atlantic. And then finally, last but certainly not least, we have this last coordinate right here, 4-0. So 4-0, this would be the fourth array. And then we come to index 0 of that, which is this 5 right here. And as you can see, this 5 already touches the Pacific and touches the Atlantic, so it doesn't have to go anywhere. It's already there. Then it says, note that there are other possible paths for these cells to flow to the Pacific and the Atlantic. So that's like looking at this 5. We went this way and this way, but like we already said, we could have went this way or this way. There's other paths we could have taken. So let's look at example 2. Example 2 is a little bit simpler. We just have our input heights, 1 cell 1, which is 1, and so our output is that only cell, which would be 0, 0. Explanation says the water can flow from the only cell to the Pacific and the Atlantic Oceans. So I hope that made sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Now, for this solution, what we are going to do is, first thing, we're going to create a helper function. It's going to be a depth first search helper function. So we could just create it inside this main function by saying func dfs, open up the parentheses, _r, colon, that's going to be int, comma, then we'll say comma, _c, colon, that's going to be int, comma, ocean, colon, that's going to be in out to the array of booleans. Boom. And then we could come outside these parentheses and open up the brackets. Let's create this function. First, we need to mark the current cell as reachable for this ocean. So we could say ocean, square bracket r, square bracket c. We'll set that equal to true. Boom. Then we need to explore all 4 directions, meaning down, right, up, and left. So we're going to say for dir in, open up, it's going to be a 2D array of integers. So in 1, 0, come outside those square brackets, say put some more, then we'll say 0, 1, come outside those square brackets, open up some more. We're going to say -1, 0, come outside those square brackets, open up some more, and we're going to say 0, -1. Boom, come outside this 2D array, and we're going to open up the brackets. Then we're going to say let, open up the parentheses, nr, nc, come outside those parentheses, equal. Open up the parentheses, we're going to say R plus dir square bracket 0, come outside of that, comma, C plus dir square bracket 1. Then we need to continue our depth first search only if the new position, meaning NRNC, is within bounds, the new cell hasn't been visited for this ocean, and the new cell's height is greater than or equal to the current cell's height, meaning water can flow from a higher or equal to lower cell. So to handle that, we come underneath this let right here, and we're going to say if NR is greater than or equal to 0, and two and signs, NR is less than rows, two more and signs, we can come underneath that just to keep it clean. We're going to say NC is greater than or equal to 0. Sorry, y'all. Boom. And two more and signs. NC is less than cols or columns. And we'll define the rows and columns later on. My bad. Then we're going to say and two more and signs. We're going to come underneath that and we're going to say exclamation point ocean, square bracket NR, square bracket NC, come outside that square bracket, two more and signs, and we're going to come underneath that. We're going to say heights, square bracket NR, come outside that, square bracket NC is greater than or equal to heights, square bracket R, square bracket C. Then we come right here, we're going to open up the brackets and we're going to say DFS, open up the parentheses, NR, comma, NC, comma, and ocean. Now that's just the helper function because we are not done yet, y'all. Let me just make sure that is right. I guess this will be over here. Oh, sorry, y'all. Well, that doesn't even matter. Let's come back up here. Let's stay focused, y'all. So that's it for the helper function. Now we need to come up here. Let's define the rows and columns. So we're going to come right here to get the number of rows. We're going to say let rows equal heights dot count, and we're going to come underneath that, say let cols equal heights square bracket 0, come outside the square bracket dot count. Boom. Now we need to create two Boolean matrices of the same size as heights, which will be, and then so the Pacific will be true if water can flow from RC to the Pacific, and Atlantic RC will be true if water can flow from RC to the Atlantic. So to handle that, we're gonna say var Pacific equals is gonna be an array. Open up the parentheses. It's gonna be repeating. It's gonna be a 2D array, so it's gonna be repeating another array. Open up the parentheses, and that is gonna be repeating colon false comma count colon calls. Then we're gonna come outside this parentheses, still inside the other parentheses, and we'll say comma count colon rows. Boom. Then we could we could just copy and paste this part right here, and we're going to do the same for the Atlantic. So we could just say var Atlantic equals, and then we could just copy and paste that to initialize it. Boom. Then we're going to start our depth first search from all cells adjacent to the Pacific Ocean or the top left edges. So from top edge row 0 to bottom edge row will be rows minus 1. So we're going to come underneath this. We're going to say for C and 0 dot dot less than cols. Then we're going to open up the brackets. We're going to say DFS, open up the parentheses 0, comma C, comma, and Pacific. Then we're going to come underneath that and that's going to be the Pacific edge top, and then the Atlantic or the Pacific top edge, and then the Atlantic bottom edge is going to be DFS, open up the parentheses, rows -1, comma C, comma, and Atlantic. Boom. Then we need to start our depth first search from all cells adjacent to the Pacific and the Atlantic edges. So we could come underneath this for loop. We're going to start another for loop. We're going to say for R and 0 ... less than rows this time. Open up the brackets. We're going to say DFS, open up the parentheses, R, comma, 0, comma, and Pacific. Then we're going to come underneath that, and we're going to say DFS, open up the parentheses, R, comma, cos -1, comma, and Atlantic. Boom. Then we're not done yet. We need to collect the coordinates that can be reached, or that can reach both oceans. By coming underneath this, we're going to declare a variable called res, set that equal to a 2D array of integers. Put the parentheses outside to initialize it. Then we're going to say for R in 0 ... less than rows. Then we're going to open up the brackets, and we're going to say for C in, for C in 0 ... less than cos. We're going to open up the brackets, and if a cell can reach both the Pacific and Atlantic, then we're going to add it to the result. So we're going to say if Pacific square bracket R square bracket C and 2 and signs Atlantic square bracket R square bracket C. We're going to open up the brackets, and we're going to say res dot append, open up the parentheses, open up the square brackets R, comma C. Then we could come right here, and all we have to do is say return res. Boom, y'all. That should be all she wrote. Let's run it before we submit it. Make sure it runs correctly. Cannot typo. Let's add an S right there. And let's run it again. See if that did the trick. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 3 milliseconds beats 82.35% of users. Not bad at all, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the middle part. And this is the rest of it, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.